Hi, everybody. Welcome to the next week of Loom. And as we continue to complete the semester, we are moving now to Chapter 12, Reliability, Validity, and Trustworthiness. This content will be on Exam 3, which will come in a couple weeks. As you prepare for Exam 2, if you would like to do a Zoom live video for review, please let me know the time and date that you all would like to do that. I'm free any time of the day except for meals, Wednesday, Thursday, Friday this week. If y'all want to talk amongst yourselves and figure out what's a good time and let me know, that would be awesome. Or if you want to start using the discussion board to throw out some times and what day, that would be fine too. So whatever's best for y'all, just let me know. So this is one of the more difficult chapters to grasp, but I have a really good video I want to show you, so let's get started. So here are your objectives for this chapter. We're going to talk about reliability, validity, and why we need those for our instrumentation and our tests for evidence-based practice and research. We're going to talk about what those are: reliability, validity, what do they encompass? We're going to talk about outcome measures for evidence-based practice. What conclusions can we draw from our research? We're going to look at a couple of coefficients, which data is appropriate for what kind of test you're doing and what kind of research. We're going to hit that a little bit more in our next chapter. We'll talk a little bit about sensitivity and specificity in the analysis of the data in this chapter and the next chapter. So this chapter and next chapter really go hand in hand, or they go well together. And then we're going to talk a little bit, we'll hit a little bit on ROC, receiver operand characteristics. That's something a little bit newer that's being done to validate the data. Introduction. So we want to have good research that is trustworthy, and that means that the data is reliable and valid. And those are the two most important characteristics to have in our decision-making process about the tests that we choose and what tests are the best for the type of study that we're doing. So reliability, the consistency that the test results are measuring the same thing every time. Repeatability, dependability. The instrument is consistently measuring the same thing, so that's reliability. Whereas validity is the degree to which the results are truthful or accurate. And within the accuracy thing, so that the instrument that we're using is measuring what we intend to measure, so that the precision of the instrument is there, and we want that to be the case. So with evidence-based practice and research, evidence-based practice is an arm of research. We have reliability, and within those, so within reliability or consistency of the tests that we're running, right, repeatability of the test results, we have consistency, repeatability, stability, and accuracy. And accuracy is a function of reliability. The better the reliability, the more accurate the results, and we want that. And we have specificity, how often the test measure is a true positive or an actual valid result, right? And then we have, so that's sensitivity, and specificity is the capability of the test to determine true negative tests. So sensitivity, true positive tests; specificity, true negative tests. So yes, it's truly positive. Yes, it's truly negative. So sensitivity and specificity. Then relevance, the degree to which the relationship between the test and the object or the test reflects what was reported to be tested. The degree of the relationship between the test and its object. The test reflects what was reported or tested. So that's relevance. And then validity is our truthfulness, the degree to which the results are truthful. And your little white paragraph says here, reliability and validity are the most important concepts in decision-making process. If these are missing from the data, then the practitioner is unable to make an informed decision and therefore likely to have an incorrect decision. So that's not good. So we want to try to avoid that and have reliability and consistency and validity in our testing. The relationship between validity, reliability, and relevance. So a test can be valid and it can be reliable and relevant. So a test can be reliable but not valid, relevant but not reliable, but a valid test will always have some degree of reliability and relevance. What? I'm going to show you a video so that we can understand more better. We can understand these concepts better. Another pictorial about the relationship between reliability, relevance, and validity is a Venn diagram here. And this, we want the reliability and relevance to be strong, and the stronger those are, the more valid our test. So the most reliable and the most relevant information, instrument data collected, then that will be the most valid. Okay. So validity can exist without relevance and reliability, and reliability and relevance can exist independently of validity. So a test can be reliable but not valid, and be relevant without being reliable. But a valid test will have some degree of validity and reliability and relevance. So I got the video right here I'm going to show you guys. I'm going to switch over. Hi, switching over to the video. So I'm going to have you guys watch this video.
In this video, we are going to talk about reliability and how to distinguish it from validity. Hi, and welcome back to Physio Tutors. While validity is the degree to which a test or tool measures what it claims to measure, or in other words, the accuracy of a test, reliability is the degree to which a test or tool produces similar results under consistent conditions, or in other words, the precision of a test. A good reliability of a test or tool is important because if the people who interpret the test cannot agree on the interpretation, the test result will be of little use. We can distinguish between intra-rater reliability and inter-rater reliability. Intra-rater reliability relates to the agreement between different measurements of one person, and the inter-rater reliability relates to the agreement between two or more raters. Now, let's look at both concepts of validity and reliability and how they relate to each other with the famous dartboard example. The bullseye represents the golden standard. In scenario A, we hit the bullseye by chance, so this dart was accurate, while all other darts are covered everywhere over the dartboard. So we had bad precision, or in other words, poor reliability. An example could be a pivot shift test, for example, for an ACL tear, which is an accurate test but hard to perform. So if you are untrained, it could be that your results are not consistent. In scenario B, we are precise or reliable because all of our shots land together, but we are not accurate because we didn't hit bullseye once. An example could be a scale that always measures 5 kilos too much. So our daily weighing would be pretty consistent, but not accurately displaying our actual weight. In scenario C, we are neither reliable nor accurate. And in scenario D, we are both reliable and accurate. So to sum it up, reliability is an important concept in statistics, and without a good reliability, the best clinical test in the world will be useless because every test always relies to at least some degree on subjective interpretation by the observer. With training and with precise protocols, you will be able to improve the reliability with which you are performing clinical tests and measurements. All right, so this was our video on reliability.
Okay, so I think that video does a really good job of describing validity and reliability and where some exist and where none exist. So we'll talk a little bit here in a few slides about interrelated and intra-related, but just to review really quick. So intra-related is one person and they get multiple results. And interrelated is you have multiple folks and you hope to hit the same mark. That's intra and inter explained here. And then the bullseyes that the video showed was A is accurate, but it's not very reliable because it's not hitting where we want. B is not valid, but it's reliable because all the X's are clustered over here, but not in the bullseye. And then C is neither reliable or valid because it's everywhere, and D is both valid and reliable, and that's what we really want. So I love that video, and there's a link to it on the content page if you can't link out to it here. So relevance, the degree of the relation between the test and its object. So we want it to be most relevant, and we want it to reflect that the test reflects what is reporting in the testing, like the patient's weight, like we talked about in the last slide. Moving on to the next slide, reliability then. Reliability is the proportion of the observed score that is the true score, the accurate score, the true positive. So within this diagram here, we have a true score and then the observed score. There will always be some error in the scoring, so it's not 100% true score. There will always be a percent or a portion of it that will be an error score. And then reliability, so we want consistency of the data and repeatability. So we do multiple tests with different people, and we hope to get consistency in the scores. And the observed score is the score or the results. And then we have that error that we were talking about. And the reliability is the degree that the observed score of the test reflects the true score. So we want that to be nearly to 100% of that as we can, but there's always a little bit of error in your scoring. So, but we want to decrease those errors. And then there's different kinds of reliability coefficients that we can talk about. And the first one is called the Pearson product moment correlation. And that's our calculation of the consistency between the observed score and the true score. So it's usually -1 to +1, and that's represented in the reports as a R. So our little r is between -1 and +1, right? And the PPM, the Pearson product moment correlation, you might see it referred to as PPM. That is an inferential analysis technique conducted to examine bivariate correlations in studies. So two different things, right? Two variables and the extent of the relationship between those two variables. And the data are collected from a single sample, measures two variables, and those are from each study participant. The data are obtained from two related participants, breast cancer incidents and moms and daughters. Correlation analysis provides two pieces of information about the data: the nature of the relationship, positive or negative, -1 to +1, between the variables, and the magnitude or strength of the relationship. The outcomes of correlational analyses are usually symmetrical, and that means that the analysis gives no indication of a direction of the relationship, but that one does exist. So it is not really possible to establish a correlation between if A leads to or causes B or if B causes A. But the focus is on the correlation analysis and the extent to which there is a relationship, right? And when we interpret the results of the -1 to +1, the R is the degree of the relationship between the two variables. So 0 would be no relationship, and -1 would be a negative relationship or most negative, and then +1 would be the most positive or relationship. So it depends on what we're looking at, where we really want that to be. right? If the R is between 0.3 and negative 0.3, that's considered a weak relationship. If it's 0.3 and 0.5 or negative 0.3 and 0.5, that's considered a moderate correlational relationship. And if it's 0.5 minus plus or minus, then that's considered a strong relationship. So our R is really important when we're looking at quantitative data. Then we have the guy on the video was talking about interclass reliability and intra-class reliability. And again, the interclass is two and only two variables. So we have two variables only in interclass. In intraclass, we have more than two. That's the difference between those. Okay. And then we have consistency of the measure. That's called test-retest reliability. And we want that to be high. We want that number to be that there's good test-retest reliability, and that improves the stability of the test. So our equivalency reliability is two forms of a test that report the same results. So that's a good thing because that then we can compare the tests or tools. Then we have internal consistency. So we take half of the test. So the test is divided in half, and we look to see if each half is consistent with the other half. That's basically what internal consistency is. And the difference between, again, the inter and intraclass is the number of variables. So we have two or more, or not just two, right? And then we use a test called analysis of variance, an ANOVA test. That is a statistical test from SPSS that says how much correlation there is and what is the relationship between the variables. And that helps with our errors and reliability scales there. Objectivity, the reliability of the scores is assigned by the judges of the reviewers. So we have multiple reviewers looking at the scores, and if they're if they equal each other, that's good. So that's also called the standard error of measurement, SEM, and that reflects the differences in the observed score and the true score. Okay, moving on. So determining the accuracy, the standard error of measurement. So we use the SEM, and that's a mathematical equation. You don't have to know the mathematical equations, but it does allow for some error. And there's a standard deviation there. We'll talk a bit more about standard deviation in the next chapter. We want our confidence interval usually at 95%. So that's important to know when you're looking at the next exam, that our confidence intervals are 95%. So we want to only have about 5% error in our measurements. So we want it to be really strong. And then that's for continuous data, and we'll talk a bit about the different types of data here in the next chapter. And that's where our continuous type data, ratio interval data, we'll talk about what that is. And then for our nominal data, which we use our chi-square statistic, and that just looks at a relationship a little differently because the data is not a ratio or continuous data. Moving to the next slide. Factors that affect the objectivity and the accuracy of the test. So here we have fatigue, right? And fatigue is the person taking or collecting the data has decreased reliability because they're fatigued. So for these factors, look in chapter 12 on page 285 and 286. This will tell you a bit about the different factors that affect objectivity and accuracy. So fatigue in the participant or the researcher, practice, that all the participants have the same amount of practice, and more practice the person becomes at the test, then the more the reliability is improved. Timing, that is there time between the pre-test and post-test, so we don't have the Hawthorne effect, and so the reliability decreases with the shorter amount of time between tests. And then homogeneity of the testing conditions, that it's not too hot, not too cold, that those type of things with the testing conditions, and the more sameness of the testing conditions, the better the reliability, right? Better the reliability. So our level of difficulty, the harder the test is, the lower the reliability, because it's hard for the participants to understand what's happening. Precision, the more precise the measurement means better accuracy. And then we talked about environment, we talked about testing conditions. Changes in temperature and pressure can also change the reliability of your test. As we continue, the use of reliability then, so we have stability, the test, retest, intra-class, that we have stability there, the constructing the alternative forms, and are those consistent? Let's say I have a test and I have 4 or 5 versions of the test. We want to make sure that the interrelator reliability amongst the tests is the same. And we can look at different tests in SPSS to determine internal consistency. So we have the same day test retest. We can do that split half we talked about. We can do Cutter-Richardson tests, or the coefficient alpha coefficients, to look at different types of internal consistency. Moving on to the receiver operant characteristic. This determines accuracy of test results. This is a newer type test that they're looking at. So it looks at sensitivity and specificity of a diagnostic test to see if the outcome of the disease the test is reported to measure. Usually we use those with dichotomous variables with our chi-square statistic. That's what the 2 plus 2 means. And we need to know the rate or number of individuals within the groups, our true negatives, true positives, false negatives, false positives, to be able to use this statistic. I haven't really seen it in studies, but it's coming on board. Our last slide really talks about the validity of the test is the truthfulness measure. I know I'm touching my face. I have an itch. I wash my hands. So we're going that the truthfulness measure is what it's supposed to measure. And we have logical or statistical types of validity. There are 3 types, and you will be tested on these. There's some more links in D2L that talks about these, and you can look in your book as well. For the different types of validity. We have content-related validity that could also be called face or logical validity. And the example of that is the adage or cliche, if it looks like a duck and quacks like a duck, it must be a duck. This is our content-related validity. What does it look like? It's logical. So that's content related. So remember ducks. If it walks like a duck, it quacks like a duck, that's a duck. And then we have criterion related validity, and that's based on comparisons between tests that's using the same known criterion. For example, I have a pulse oximeter and I have an ABG. And what are the comparisons between those? What other things can we think of that we have different ways? A temperature, oral temperature versus intrahepatic temperature. What is the accuracy or validity between those 2 types? And then we also have, with our criterion validity, we have divided into concurrent and predictive. So don't get confused when you're looking at the textbook or about what is concurrent and what is predictive. So concurrent is our PPM statistic, our Pearson product moment coefficient statistic, and then our predictive validity is a linear or logistical regression. So it's a different type of test that we're doing in SPSS to see what the validity of the different tests is. And then we have construct validity, which focuses on the test associated with a psychological characteristic, right? So we are attempting to develop validity for measures that exist in theory but are observable. Take pain for an example. So construct validity. Pain is subjective, and we know that pain is what the patient says it is, but we need to objectify or make that a concrete thing. So we've developed different tools that we can use, like pain scale, faces, different types of scales to measure that subjective data into an objective way. So we can look at pain, we can look at the intensity of the pain, the severity, the discomfort, what are their pain tolerances. We can look at those type of things, and that's more of a construct validity there. That's our 3 different validity types, and you'll need to know those for testing coming up. And then after that, here's your summary points that just summarize what we've just talked about. You can look at these up on the website. There's also just your PowerPoint, general without voiceover, that you can look at to look at these as well. And that concludes this one about reliability and validity. Again, probably one of the hardest chapters to understand. So I've given you some extra helps, and look at your textbook and the referenced chapter and the other textbook that's online. If you have questions, please let me know. I'm working on the assignment for this week. I think we'll use the statistical chapter for that coming up, and I will let you know what that is when I decide what it's going to be. Me and the mouse in my pocket. I'll talk to you all later. Bye.